Hello, in this video I explain how to find the area under two curves in both terms of x, vertical, and terms of y, horizontal. So um, let's look at an example. So here we have two curves. We have y equals f of x, and the other green one, the other line is the green one, y equals g of x. You want to find the area between the boundaries from A to B, right? So if you kind of go back to Riemann sums, we said that you can take the area under two curves by making small rectangles and adding up the area of those rectangles, and that'll give us your the most precise area, right? So if it's vertical, see in this example, the rectangle is vertical. Here you have the height, and here you have the width, and um, the width would be the delta x, and then the height um, would be since this is in terms of x, the height would be in top minus bottom, right? So the height for this one would be top top function minus bottom function. And then the width would just be delta x. Okay, so this is the height. And sometimes you'll have to go top minus bottom, and sometimes you'll have to go right to left. So just note that if everything is in terms of x, or if your rectangle is vertical, or in terms of x, you're going to go from top function minus bottom function. If you're going to, okay, so yeah, we'll explain that a little bit more. So yeah, key idea, rectangles have a height of f of x, top curve minus g of x, bottom curve. This is only if your rectangle is vertical, or if everything is in terms of x. And then the width is delta x. So yeah, if it's vertical, everything has to be in terms of x. So if it's in terms of x, it's from that boundaries A to B, from top minus bottom d of x, where f of x and g of x are continuous, and f of x is greater than or equal to g of x on the intervals A to B. Okay, so just note, area must be always positive. If your final is negative, that means you must have done something wrong. What if your function is in terms of y? So now, if you look at this graph, this is everything in terms of y, and you're going on the vertical axis. So I'm not vertical, horizontal. So on the y-axis. As you can see, our rectangle is going from horizontal. Then what you would do is you would take the function of the right function. So in our case, it would be I believe it would be the green function minus the function to the left, which is the other color. So if it's in terms of y, your height is right function minus left function. Okay, so if you're in terms of y, it's right function minus left function, and everything has to be in terms of y, and you must integrate with respect to y. So there's a reason why it could be good if we integrate in the y direction instead of the x direction. Sometimes you have to. The reason why is the geometry of the problem might demand it. I mean, it's just might be easier to take the integration in terms of y. Sometimes one integral will be more difficult or even possible. So yeah, sometimes you might have to take the integration of a problem that you haven't learned yet, and So you might as well just have to convert it in terms of x or in terms of y. Okay, so let's look at example one. Find the area of the region between the function y equals x squared and then y equals square root of x. So what we got to do is see how everything is in terms of x. This is in x and this is in x. It's most likely we're going to put everything in terms of x. So what we're going to do is like find the domain. And or the intersection points. So what you're gonna do is set the equation to each other. Basically, that's how you find your domain. Okay, so well, yeah, let's set each equation to each other. So it's going to be x squared equals the square root of x, right? And what I do is maybe I would have to get rid of the radical by squaring both sides. So on the left, it would be x to the fourth, and then on the right, it would be the square root of x is the square root of x squared is just x. Okay, so we'll probably have to get one side zero. So we're gonna have to get let's get one side zero. So let's move this x to the left by subtracting x, subtracting x. So you get x4 minus x equals to 0. And then what you would do from here is factor out an x. And this is x squared minus 1. And then if you want, x squared minus 1 can be factored as a perfect square. And then when you actually solve for x, you get x equals 0, x equals -1, and then x equals +1. Um, I think on this one, I think we have to stick with 0 to 1. That was part of the problem. So I think they actually told you from 0 to 1. Okay, so we can exclude -1. So that was part of the problem. It specifically said from 0 to 1. So we could exclude -1. Okay, so now we found our domain and our boundaries. Now let's go ahead and graph it. So if you want, you can, how do you graph? We know that y equals x squared is a parabola, and we know that y equals square root of x is a square root graph. We kind of know what that looks like. If you didn't know, you can make a table or you could put in Desmo. So let's just quickly make a table. So you'll put x here, and then one of your functions is x squared, and then the other one is square root of x. And then this is going to be 0. And then if you put 0 here, your output is still 0. And then when you put 0 in the square root, your output is still 0. And then our other x value we can use is +1. So when you put 1 here, 1 squared is 1 is 1. When you put here, square root of 1 is 1. So really you have how much points? So this one is 0, 0. This coordinate here, the y equals x squared graph, has two coordinates, 0, 0, and then the other one is 1, 0. And then the other function, y equals radical x, you have 2 points. One of them is 0, 0, and then the other one is 1, 1. Okay, so you kind of graph it. These aren't too hard graphs, right? We fairly know how to graph these ones. put 1 here and then 1 there. So let's graph 0, 0, and then 1, 1. So let's graph the parabola. Okay. So this graph right here is y equals x squared. Now let's use another color to represent the, what should I use? Let's use gold. And then the other one is 0, 0, and then the other one is 1, 1. And how does that look like? This is the square root graph. So the gold one is y equals square root of x. Okay, so everything is in terms of x. How would it be wise to put our, I think it's best to be, if you look at our rectangles, we draw a rectangle. I think it should be vertical. Right? So if we draw a rectangle, let's see, what would be our width? Our width would be delta x, and then our length would be, not our length, our height. Is in terms of x, it's going to be top minus bottom, right? So if it's in terms of x, it's going to be the top function minus the bottom function. In terms of y, it's the right function minus the left function. And our boundary is from 0 to 1. So our area is going to be from 0 to 1. And then it's the top function. So the top function is the golden one. It's the square root of x minus the bottom function, which is x squared dx. So now we got to integrate it. And if you want, you can rewrite square root of x as x to the 1/2 minus x squared dx. Now let's just take the integration of each term. So what is the integration of x to the 1/2? 1/2 is 2 over 2 divided by 3 over 2. So that is just going to be 2/3 x to 3/2 minus, what's the integration of x squared? 2 plus 1 is 3. So that would be 1/3 x3. And then we just take the boundaries. Here's 0 and here's 1. So you do the fundamental theorem calculus. So you do the upper boundary minus the lower boundary. So it's going to be 2/3 1 to the 3/2 minus 1/3, and then 1 to the 3rd minus bracket. This is easy. 0, putting in this is 0, 0. 0 minus 0 is just 0. So 1 raised to the 3/2 is 1, so you have 2/3 minus 1 raised to the 3rd is 1, and then times it by 1/3 is 1/3. So that would be positive 1/3. Okay. So my area for this under these two curves is 1/3. Okay, go ahead and copy and absorb. Okay, so let's move on to example 2. So example 2 says, find the area between the curves y equals cosine x and y equals sine of x from the x value 0 to pi halves. Okay, so we can only go from 0 to pi halves, but I'm still gonna find the x coordinates because there might be an extra x coordinate that we need to use. So what I'm gonna do is first set the equation to each other. So I'm going to set cosine of x equals to sine of x. So what this means is what degree gives you the same cosine and the same value as a sine value. That would be pi over 4, right? So if you look at pi over 4, it has an x coordinate or a cosine of radical 2 over 2, and then it has a y coordinate of radical 2 over 2, correct? Okay. Now, what we're going to do next is we're going to, so we're going to definitely use pi over 4. That's part of, I think that'll be our intersection because you know how cosine goes up to the max, and then sine starts at the origin. So they are going to intersect. And wait, so if we're going, okay, so here's our, let's kind of make a table. Here's our function y equals cosine of x. We have, let's plug in 0. That would be cosine of 0, which is 1. So that would be 0, comma 1. And then if I plug in y of pi over 4, cosine of pi over 4 is radical 2 over 2, or about 0.707. And then the next one is pi halves. So cosine of pi halves is cosine of pi halves is 0. So you have 0, comma 1, pi over 4, comma 0.707, and then pi halves, comma 0. And then let's do the other function, y equals sine of x. So if I do y of 0, sine of 0 is 0, y of pi halves is sine of pi halves, which is 1. And then y of pi over 2, oops, I forgot pi over 4, sorry. Not pi, sine of pi over 4 is still radical 2 over 2, or 0.707. And then y pi halves is uh, 1. So you have coordinates 0, 0, pi fourth, comma 0.707, and then pi halves, comma 1. Okay, I think now we can start graphing. So which one do you want to graph? Let's graph the sine of x. To use Galaxy. So you have 0, 0 here, and then pi over 4, it's like, oh, put 1 here. Pi over 4 is like 0.77, so that's like really close to 1. And then at pi halves, it is exactly at 1. Okay, so this is y equals sin of x. Now let's do, what color should we use? Let's use gold for the other one. So the other one is 0, comma 1. And then pi over 4, it's 0.707, 0.707, so it'd be right here, and then at pi halves, it would be 0. Okay. So the golden one is y equals cosine of x. Okay. Now, if you look at our image, let's go back to let's go back to the ocean font. So if you draw your rectangles, it's obviously vertical, so everything's in terms of x, which is good. But the only problem is we have to break it down into two different integrals because it stops right here, right? It intersects here, so we can't just say 0 to pi halves. We have to break it down into two separate integrals. So the first integral will be from 0 to pi fourths, and then the second integral will be from pi fourths to pi halves. Okay, so area equals 2. So first one would be from 0 to pi fourths. And since it is in terms of x, we have to do top minus bottom. So the top one would be sine of x. Minus the bottom, which is this, wait, no. I made, the top one is the golden one, which is cosine of x. Minus the bottom, which is sine of x. Okay, and then the second integral would be from pi fourths to pi halves. And this time the top one is the galaxy font, which is the sin of x. And then the bottom would be the golden one, the cosine of x, right? Okay, now we just got to integrate. So let's do the first one right here. What is the integration of cosine of x? It is positive sin of x. What's the integration of negative sine of x? It becomes cosine of x. And we're evaluating the integral from 0 to pi fourths. And then let's take the integration here. What's the integration of sine of x? It is negative cosine of x. And then what's the integration of negative cosine of x? Is negative sine of x. From pi fourths to pi halves. Okay. So now let's do the fundamental theorem. So let's do this one right here. Do the top minus bottom. So that's going to be sin of pi over 4 plus cosine of pi over 4 minus bracket sin of 0 plus cosine of 0. So the sine of pi over 4 is exactly radical 2 over 2. The cosine of pi over 4 is also exactly radical 2 over 2 minus bracket the sine of 0, I believe it's 0. The cosine of 0 is actually 1. So radical 2 over 2 plus radical 2 over 2 is 2 radical 2 over 2 minus 1. I guess the radical 2 cancels, so you're just left with radical 2 minus 1. Just for this section, now let's do this section right here. So it's going to be negative cosine of pi halves minus sine of pi halves. minus bracket negative cosine of pi over 4 minus sine of pi over 4. Okay, so what is the cosine of negative pi over 2? It is, well, cosine of pi over 2 is 0. Cosine of pi over 2 is 0. Minus the sine of pi over 2 is 1. Minus, this is negative. What is the cosine of pi over 4? It's positive radical 2 over 2, but there is a minus. Sine of pi over 4 is positive radical 2, but there is a positive radical 2 over 2, but there is a minus. Okay, so if you look here, what's negative? This one here, negative radical 2 over 2 minus negative radical 2 over 2. That is negative 2 radical 2 over 2. And you have a minus, and then you have negative 1. And then we know that 2 minus this becomes positive, so you have negative 1 plus 2 radical 2 over 2. The 2's cancels. You're left with this radical 2 minus 1 plus radical 2 minus 1. Then you can collect like terms. So you can collect this radical 2 here, this other radical 2 there. That would be 2 radical 2. And then you can also collect the negative 1 and the negative 1, which is negative 2. Okay, so that would be your final answer. Okay, let's move on to example 3. So example 3 says, find the area of the region of y equals sin of x and y equals e to the x. Run the boundaries x equals 0 and x equals pi half. So what am I going to do? So if we're going from 0 to pi halves, do I really need to find the boundary, the point of intersection? I don't think so. I don't think there is a point of intersection because if you set each other, yeah. So what I'll do is just make the table to graph the points, right? Okay, so the first one would be the x value, and then this is e to the x, and then this is sin of x. So that first x value I'm going to use is 0. The next one, since we're going from pi 0 to pi halves, I could find there's some extra points from pi halves. You could use pi 6, pi 4th, and pi 3rd, right? So that's what I'm going to do. I'm going to use pi 6, pi 4, pi 3, and then pi halves. Okay. And then I'm just going to plug it in. So let's plug in our x value 0. E to the 0 is 1. And then sin of 0 is 0. And when you put pi over 6 and e to the pi over 6 in the calculator, you get about 1.7. And then sine of pi over 6 is exactly 1/2 or 0.5. Pi 4th is 2.2. Sine of pi over 4 is 0.7. Pi over 3, e to the pi over 3 is like about 2.8. Sine of pi over 3 is exactly radical 3 over 2, but in decimal it's about 0.87. And then the next one is pi halves, which is about 4.8, and then 1. go ahead and put it in your graph. Zero, and then 5/6, 5/4, 5/3, and then 5/2. And then let's on the y-axis, let's do 1, 2, 3, 4. Okay, so now we have our graph. If you want to write it as a coordinate, that's fine. So let's start with the y function e to the x. You have 1, 2, 3, 4. We have 5 coordinates. So the first coordinate is 0, 1. The next one is 5/6, 1.7. And then you have 5/4, 2.2. And then you have 5/3, 2.8. And then 5/2, 4.8. And then the other graph is y equals sin of x. So you have 0, 0, 5/6, 0.5, 5/4, 0.7, 5/3, 0.87, and then 5/2. Okay, so which one would you like to graph? What color should we use? We should use let's use rose gold for y equals x. So 0, 1, 5/6, 1.7, 5/4, 2.2, 5/3, 2.8, 5/2, 4.8. Okay, so if you kind of graph this, it should look something like this. So this is y equals e to the x, and then let's graph the other one. Let's graph using, let's see silver. So the first for the silver will be y equals sine of x. So first point is 0, 0. The next one is 5/6, 0.5. So that would be right here. 5/4, 0.7. 5/3 is 0.8. And then 5/2 is 1. Okay, so if you connect the dots, this is y equals sin of x. Okay. Now, everything is in terms of x. So if you look at if you kind of like draw the rectangle, right, everything is in terms of x, so in vertical. And our boundary, so the area is going to be, how we set it up is from 0 to 5/2. Since it's in term of x or vertical, it's going to be the top minus bottom. So the top function, I believe, is going to be e to the x minus the bottom function, which is sin of x and d of x. Okay, So now let's just take the integration. What's the integration of e to the x? It is e to the x. What is the integration of negative sine of x? It is positive cosine of x. And we are going from 0 to 5 halves. So do the upper minus bound lower. So that's going to be e to the pi halves plus cosine of pi halves minus this one would be e to the 0 plus cosine of 0. So this is e to the pi halves. Cosine of pi halves is 0 minus e to the 0 is 1. Cosine of 0 is 1. That's e to the pi halves. Minus bracket 1 plus 1 is 2. That's e to the pi halves minus 2. And that is your answer. We'll just keep it as exact value. Okay, so that was example 3. Let's move on to example 4. So find the area of y equals x squared and the function y equals 4x minus x squared. This time they do not tell you where the domain is or where the point of intersection, so we're gonna have to find it. So how do you find it? Well, everything is in terms of x, so that's good. Now let's just define the domain and the point of intersection is you simply set the equation to each other. So you're gonna set x squared equals to 4x minus x squared. Okay. And then you're gonna get, we're gonna probably factor this, so we're gonna have to get one side 0. So I'm gonna add x squared to both sides. Try 4x. This cancels, this cancels. So 1x squared plus 1x squared is 2x squared, right? And then you have negative 4x equals 0. And then it looks like we could take out 2x. Yeah, 2x, so this is x minus 2. So when you actually solve for, you get x equals 0, and then x equals 2. Okay, so it's most likely we're going to go from 0 to 2. Okay, now we're going to have to graph this, so we'll have to most likely make a table, or you could just put in decimal, it's fine. We got x squared, and then 4x minus x squared. Okay, so let's use the x value 0. When you plug in 0, you get 0. Over here, when you plug in 0, 0 minus 0 is 0. And then if you plug in 1, 1 squared is 1, and then 4 times 1 is 4 minus 1, which is positive 3. And then 2. 2 squared is 4. 4 times 2 is 2. 4 times 2 is 8 minus 4, which is 4. Okay, so if you look at the y equals x squared function, you get 3 coordinates, 0, 0, 1, comma 1, and 2, comma 4. And if you look at the other function, y equals 4x minus x squared, you have 3 coordinates, 0, comma 0, 1, comma 3, and 2, comma 4. Okay. And it is time to graph. Okay, so what are we going to do here? So which one do you want to graph? It doesn't matter. Let's use gold. Let's use gold for y equals x squared. So it would be 0, 0 here, 1, comma 1 there, and 2, comma 4 there. Okay, connect the dots. So this is y equals x squared. And then the other one, let's do bronze. So we're going to graph this one, y equals 4x minus x squared. So you have 0, 0, 1, comma 3, 2, comma 4. Okay, the bronze is, wow, let's use another font. How about, let's do rose gold. Okay, so I don't know if that helps. So the rose gold is the function y equals 4x minus x squared. Okay, so as you can see, if you draw your kind of like your rectangles, it's going to be vertical. So it's going to be the height would be top minus bottom, and then the width would be delta x. So area equals from 0 to 2. And then it's going to be top function minus bottom function. So the top function is 4x minus x squared minus the bottom function, which is x squared dx. So this is going to be 4x minus x squared minus x squared dx. Is there anything we can combine? Yes, we can combine the negative x squared. Okay, so negative x squared minus negative x squared is negative 2x squared dx. And then we just take the integration of each set of each term. So the integration of 4x would be 4x squared over 2 minus the integration of negative 2x squared is negative 2x cubed over 3. So that would be 4 divided by 2 is 2x squared minus 2/3 x cubed from the boundaries 0 to 2. Okay, so you do the upper minus the lower. So it's going to be 2 squared minus 2/3 2 cubed minus bracket, and then the boundary, the lower is just 0. 2 squared is 4 times 2 is 8 minus 2 cubed is 248, right? 2 cubed is 248. 8 times 2 is 16 over 3. And then if you want to simplify this, this has an LCD of 3. 8 times 3 is 24. 24 minus 16 is exactly 8. So your area would be area equals 8, 3. Okay, let's move on to the next one. Example 5 says find the area of the function 4x plus y squared equals 12 and x equals y. You do not find, we do not have, they're not given our domain or the point of intersection, so we got to find it. So how do we do that? Is set the equation to each other. So we set this to this you want, you can read x equals y is the same thing as y equals x. Okay, so if we set so it's going to be oh, I know what we have to do. We have to, if we're going to put it in terms of x, we have to solve for y. So over here, I'm going to subtract 4x, and then you get y squared equals to 12 minus 4x, and then take the square root of both sides. So y equals plus or minus square root of 12 minus 4x. Okay, and then what I would do next is set the equation to each other. You have this one. Okay, so it would be square root of 12 minus 4x equals to x, right? Then I would square both sides. So over here, when you square this, the radical disappears. So you're left with 12 minus 4x. Over here, when you square this, it's x squared. And then I guess you have to get one side 0 because we're going to factor this. So move this everything to the right. So I'm going to add 4x, and subtract 12. Subtract 12. You get 0 equals to x squared plus 4x minus 12. And then factor this out. This is x, and then negative, what two numbers multiply negative 12 and added gives you 4, 6 and 2. Okay, and then when you actually solve for it, you get x equals negative 6 and x equals positive 2. Okay, and then if you make a table, x, y, says y equals plus or minus 12 minus 4x. So we can only go from negative 6 to 2, so we'll use negative 6. I guess we can also use negative 4. And then we can also use negative 2. And then we can also use 0. And then also stop at 2. Okay, so this is y equals x, by the way. So if we plug in negative 6, your output is negative 6. Over here, this is negative 4. Over here, this is negative 2, 0, and positive 2. Okay, over here, when you plug in negative 6 into this function, you get plus or minus 6. Over here, you get, when you plug in negative 4 into this function, you get plus or minus 5.3. The next one would be plus or minus 4.5. The next one would be plus or minus 3.5. The next one would be plus or minus 2. Okay, so if you kind of look at our functions, so the function y equals x, we have the coordinates negative 6, comma, negative 6, negative 4, negative 4, negative 2, negative 2, 0, 0, 2, 2. And then the other one is y equals plus or minus 12 minus 4x. And we have several coordinates for this one. So we have -6, -6, -4, 5.3, -2, 4.5, 0, 3.5, 2, 2, and you have -6, 6, -4, -5.3, -2, -4.5, 0, -3.5, 2, -2. Okay, so now we can start graphing. Okay, so what color would you like? I like to use green. I like green. Dark green or light green. Now let's use dark green. And let's graph y equals x. So the first point is at -6, -6. This one is -4, -4, -4, -4. The next one would be -2, -2. The next one would be 0, 0. The next one would be 2, 2. Okay, so you know that kind of looks like a linear line like this. Y equals x. And then the other one, let's use, what color should we use? Let's use red. And the next one is this parabola. So first point is -6, -6. It literally overlaps the green one. -4, 5.3. The next one is -2, 4.5. The next one is 0, 3.5. The next one is 2, 2. It overlaps the green one. The next one is -6, +6. -4, -5.3. -2, -4.5. 0, -3.5. And then 2, -2. If you look at if you look at our area, do you think it's best to do it in terms of x or in terms of y? What do you think? So in terms of x, you would do your vertical, right? The thing is, if you do it in vertical, you're going to have to split it up into two boundaries, which is a pain, which is a doable, but it is a pain. If we do it in terms of y, we don't have to anymore. That's what I'm going to do. I'm going to put it in terms of y, and it's going to be horizontal. The rectangle will be horizontal. So if it's horizontal, now the height would be right minus left. And yeah, the height would be right minus left. And then, so we kind of have to do some algebra first. So the first function is already in terms of y, it was x equals y, right? The second one, it wasn't. We had 4x plus y squared equals 12. So we have to put it in terms of y, basically solve for x. So I'm going to subtract y squared. And then you have 4x equals to 12 minus y squared. Divide this by 4, divide this by 4. X equals 12 minus y squared with 4. Okay. So which one is the right and which one is the left? So I think the right one is this one, right? Hold on, we can simplify this. We're going to divide it each term by 4. So 12 divided by 4 is 3 minus 1/4 y squared. Okay. So your area is going to be from, in terms of y, our smallest y value is -6. And in terms of y, the highest y value would be at 2. And then it's the right minus left. So our right is this one. So it's 3 minus 1/4 y squared minus the left, which is y, dy. Okay, so now we just have to take the integration of each term. So the integration of 3 is 3y. The integration of -1/4 y squared is, it becomes -1/12 y cubed. The integration of -y is -1/2 y squared. And then we're going from -6 to 2. Okay, so do your fundamental. It would be 3 times 2 minus 1/12, 2 to the third minus 1/2, 2 squared minus bracket, it would be 3, and then do the 3 times -6 minus 1/12, -6 third minus 1, -6 squared. If you do put it all in the algebra, your final answer will be 64/3, positive 64/3. Okay. Okay, last one, and then we'll end this video. Oops. Let's see. Happen. Okay, here we go. Example 6. So it says use calculus to find the area of the triangle with vertices 0, 5 to -2 and f5, 1. So how would I do this? What I would do is draw it, right? Okay, so 0, 5 would be 1, 2, 3, 4, 5. Let's call this A. Actually, let's not call that. Let's just label it 0, 5. And then the other one is 2, -2. And then the next one is 5, 1. Okay, so if you connect the dots, so how do you find the area of this triangle? So let's call this line g of x. Because do you see that these lines represent linear lines? So we're going to have to find the equation of those 3 linear lines. And then let's call this line from this point from here f of x. And then finally from 2, -2 to 5, 1, we'll call it h of x. So let's find the area. Let's find the equation of those 3 lines. So let's start with f of x, if you like. F of x is f of x goes through the point 0, 5 and 5, 1. Okay, so let's find the slope. This is x1, y1, x2, y2. So my slope is going to be y2 minus y1, so that's 1 minus 5. And then it's going to be 5 minus 0. So 1 minus 5 is -4. 5 minus 0 is 5. Your function is f of x equals -4/5 x. And then your b value actually is given. Your b value is the y-intercept, which is, it actually tells you 0, 5, which is 5. Okay, I'm going to kind of box it. This is not our answer. Now let's find the line for h of x. So h of x goes for the point 2, -2 and 5, 1. So just like the other one, we got to find the slope. There's x1, y1, x2, y2. So my slope is going to be y2, 1 minus y1. And then this is 5 minus 2. 2 negatives becomes a positive, is 3. And then 5 minus 2 is 3, which is 1. So our slope is 1, but this time they do not give us your b. So it's going to be 1x plus b. So to find the b, you're going to pick a point. It doesn't matter. It has to be between these 2 points. So it doesn't matter what point you use. If I use the point 5, 1, plug it back in. H of x is 1, and your x is 5 plus b. So it's 1 equals 1 times 5 is 5 plus b. Subtract 5, you get b equals 1 minus 5 is -4. So h of x is 1x minus 4. Okay, and then we're missing. What are we missing? We are missing. We did g of x. So let's find that. So g of x goes through the point 0, 5 and 2, -2. So this is x1, y1, x2, y2. So my slope is -2 minus 5 over 2 minus 0. -2 minus 5 is -7. 2 minus 0 is 2. So my slope is -7/2. They also give you your b, which is 5. So g of x is -7/2 x plus 5. Okay, so here's our 3 linear lines. So how do we we got to find the area of this. So what I would do is split the triangle into two parts. And just apply the rule. So the area, I guess we can set it up as area equals. We're going to set it up into two boundaries. We're going to do it from 0 to 2 and then 2 to 5. And then from the boundary 0 to 2, the function would be f of x minus g of x of d of x. Plus the boundaries from 2 to 5 is going to be f of x minus h of x of d of x. Okay. So f of x, this is why we found the original line is negative 4/5 x plus 5 minus g of x, which is negative 7/2 x plus 5. Plus the integral from 0 to 2, and then f of x is negative 4/5 x plus 5 minus h of x, which is x minus 4 dx. So if you FOIL this out, this would be positive 7/2 x. This would be minus 5. And the 5's cancels. So you're left with 0 to 2, and then you have negative 4/5 x plus 7/2 x dx plus, oh, this should be 2 to 5. And then this would be if you kind of clean it up a bit, it would be negative 4/5 x minus 1x plus 9 dx. Okay. So all you got to do is take the integration of each term. So if you start here, take the integration of each term and then apply the fundamental theorem. The same here, take the integration of each term and then do the fundamental theorem. And your final answer should be 27/2. Okay. Go ahead and try it. See if you do get 27/2. Go ahead and check your work. Okay, so that wraps it up for this section. It was a longer video, but yeah. So this is the area under our curves.